So that breaks. So there are many reasons. I'm also a big
Yeah.
fan of having a landing area. Uh, okay, fine. Now from landing to drag anchor. Okay, now let's go really deep. Let's make it difficult.
Yeah.
Now so 3NF, everybody knows what 3NF is, third normal form. Now this data vault comes in. Data vault has a concept of satellites, hubs, and links. And data vault normally look into business domain and entities. And within entities, they end up creating known key values into satellites. And based on the requirements, they can end up creating multiple satellites. So their satellites start growing. Hub and link remain same. Now we go towards focal. Focal have preset of tables where rows keep growing and number of tables and or 5, 6 dimension within the table they have it. And you end up with a static number of models, you end up loading rows where, for example, if there are 10 columns, 5 column will have rows, the other five will not have. So they play like this. Now let's come to us anchor. Now,
Yeah.
a basic question, a stupid question. What is anchor at the level of data modeling? How it works? Go
Yeah.
deep, how
So,
much
yeah.
technical you
Okay.
can go, just go for it.
Yeah. Perfect. All right. So it's similar to the way Data Vault works, and Focal also to some degree. So if you in Data Vault have hubs, links, and satellites, we have the corresponding constructs also. We have anchors, which correspond roughly to hubs. The links, we have something called ties, also roughly corresponds to links. They represent relationships. And anchors represent core business entities. And then we have attributes, which are like satellites, except if you were to take your satellite and break it apart, so you would have one table per each attribute that you have within a satellite. So normally, if you have like a customer name and a customer number, you would have perhaps both of those in the same satellite. Whereas in anchor modeling, they will be in two different attributes. You would have a name attribute and a customer number attribute, and those will be two different tables also in the database. That's basically what the sixth normal form is. You decompose everything as far as possible. And the benefit of doing so is, of course, that you don't have to make any decisions up front about what belongs in the same satellite or not, because in anchor modeling, everything is in its own attribute. And that also means that if you want to grow and expand your model over time by adding a new attribute, this is an operation where you actually add a new table in the database. So you never modify any of your existing tables unless, of course, you made some sort of error. But under normal operations, when you extend a model, an anchor model, the extensions become new tables in the database. And that's actually quite a good, it's beneficial from in a number of ways, because when you add a new table, it's sort of like an instantaneous operation. It's not a heavy operation to add a new table. It also means that if you have anything working against with your existing model, you know that this will keep working as long as you haven't made any errors. It will continue to work the way you want. So you can actually sort of decouple extending your model from extending whatever is using your model. So you can decouple that in time. So it's also one of the things that people who use anchor modeling for OLTP systems, they really like this fact that it's so easy to extend the model while still ensuring that whatever was working with the old model will still keep working.
Yeah, okay.
And so sorry. So let's just get back quickly to those three key concepts. So we have anchors, we have ties, and we have attributes. But we have a fourth construct as well that's not very well defined anyway in the other techniques. And we call this a knot.
Not.
Knot, like the thing you tie together.
Yeah.
And this is sort of like a lookup or reference table. So Data Vault has reference tables, but it's like loosely defined what those are. In anchor modeling, we have the knot tables that are very well defined what they actually do and what they are. So they are a lookup or reference table. So they constrain what values you can put into an attribute to a specific set of values. Sort of like if you're a programmer and you define an enumeration, it's sort of like that. That's what a knot is. So we have this concept as well on top of that. So it's four different concepts within anchor modeling that you can work with when you build your models.
Okay, so just to correlate this with data vault, normally data vault, the satellites are designed in such a way, of course, you have a business requirement and you end up creating an entity-based satellite, but up to the level of granularity. So they create that up to satellite. Now, new column comes. If that new column can fit into the same granularity of the satellite, you can add it into it. But the moment the granularity change, they don't mind end up creating a new satellite. But what you are saying here is in Anchor, based on the key, every non-key column, it means in these tables, your tables, you will always have a key and a non-key column all the way around, right? So
Yes.
once the data is written, it will never go away. So what is the number of columns you have? Because I foresee you might have transaction, end date into it as well, some metadata columns as well. Are there any?
Yes. Yes. So like you said, an attribute consists like of a key column and a non-key column. And it's also important to note here that we don't really specify particularly what this key column should be. So while it would be possible, for example, to use like a hash of the natural business key as the key there, it's not something that we recommend. Usually what we like to do is to have like a dumb key, like just a number from a sequence. So like what we usually call a surrogate key. So we normally use surrogate keys. So what you find in the attribute is this surrogate key and a non-key value. And of course, if this is something that can change over time, you also need some sort of timestamp in there. So we have also 4 attributes that can change over time. We have this additional column that contains the time of the change. So when a value changes, like let's say my hair is turning gray, the point in time when my hair turned gray will be the time point there. And we also have, and this is also an optional column, if you want to use metadata or not. If you want to use metadata, you can have a 4th column within the attribute table, which is a foreign key to a metadata structure. So we don't put like source system or load date or something directly into the attribute table. So rather we have like a foreign key that points to a metadata structure that can be as rich as you want. So if you want to capture lots of metadata, you do that in that metadata structure, and you get a number there that corresponds to whatever metadata you've inserted, and maybe it's number 42, and that's the foreign key that you reference from the attribute table. And the reason why it's optional is like in an OLTP system, you rarely keep any metadata because everything is coming from one and the same place. But in a data warehousing, keeping metadata is sort of crucial because it helps you with auditability, and it helps you if things go wrong in data warehouses. So you need to back out, like we loaded a batch, but it was the wrong batch or something was wrong with it. So I need to quickly get it out of the data warehouse. Then metadata is crucial because then I can easily identify which rows in my data warehouse came from this faulty batch, and I can remove it easily from the data warehouse.
Okay. So now when you say you have these dates, which is a concept of slowly moving dimensions, right? So that concept is in all of your tables. Do you have, because see, slowly moving dimensions concept, I would say, can work on reference tables and code tables. Reference table, I'm referring like a customer. Code table, I am referring like a country or city codes, right? But there are third set of tables, transactional tables, which are normally huge. Do you also keep this dimensional concepts over there, or you don't?
Oh, okay. So that's a really good question. So one of the things that we decided early on was that the concept of a transaction is also a core business concept.
Yeah.
So whatever a transaction is, like a purchase, for example, that will become an anchor in an anchor model. And this is something that other ensemble techniques have also adopted now. So within Data Vault, you have like the keyed instance hubs and stuff like that. So we had that from the beginning in anchor modeling, and these transactional anchors, if you want to call them that, normally what happens there is that attributes of a transaction, they won't change in time. I mean, if you look at a transaction, it happens at a certain point in time, and it cannot change because once it's happened, it's happened.
Yeah.
So normally what we do there is to use something we call static attributes, and that's an attribute where you don't have the timestamp. So we have two categories of attributes. We have static attributes and we have historized attributes.
Okay.
So the attributes surrounding that transaction anchor are normally static attributes, and the time of the transaction is like a regular attribute. It's just an attribute that has the time point when the transaction happened as its value. So that's the way we normally model transactions within anchor modeling. That being said, anchor modeling is also one of the techniques that supports bitemporal modeling. What bitemporal means is that you don't only handle versioning, you also handle corrections that you need to do within the data warehouse. So let's say, for example, if we take that transaction, it's me making a purchase, and we enter today's date for this purchase into the data warehouse. But at some point later, like I said, normally that date shouldn't change because once it's an event, once it's happened, and it's at a certain time. But maybe someone made a mistake, and it shouldn't have been registered as happening today. It was actually yesterday. So then we need to make a correction, and then we have two options. Either we remove this row that is bad from the data warehouse and insert the correct value. So we sort of destroy the history of us having made a mistake. We cannot see that after we've made the correction. But if we want to keep a history of sort of the mistakes we've made, then we also need a second timeline, which is like why we call it bitemporal. And with that second timeline, we can actually keep a history of our mistakes as well. So in that case, we will also in anchor modeling have a time within, or at least related to this row that we have that's stating that I made a purchase today. And then we can actually introduce a new row saying that the purchase was made yesterday, but we still have that row in the database saying that it was made today, but that's invalidated by the more recent row saying that it was yesterday. So we have two timelines.
Yeah, so you have another column for that kind of date.
Yeah, it's actually it's not a column. So when you do bitemporal, we have a separate table. So So what we do is we have like this attribute table, and the attribute row in itself will also get an identifier, an ID column. And then you have a separate table